to talk about this type of problems. Okay, what's the ideal thing to do with this type of problem? With this type of problem, where it's important to get the vertical asymptote, the horizontal asymptote, the zeros, if there is any, the empty dots, if there is any, and the y-intercept. Okay, why is that important? We'll see. Okay, so first of all, let's just see if we'll have any empty dots, because the empty dots usually we factorize to make it easy to get them, but we'll see if we have any empty dots. Hey, there's no empty dots, so we don't have to worry that much about factorizing. Okay, so there's no empty dots, but I'm looking at it and we'll have to factorize if we want to get the vertical asymptotes for this one and for, well, no, not exactly for this one. This one's fine. We can do it. Okay, so let's start off with the g. Okay. So with the function g of x, the first step to get the vertical asymptote is to factorize this one so we can equal it to 0. How can we factorize? Whenever we have something like this, we gotta see like what can I multiply that gives me -8, but like if we sum that product, if we add each value, it's gonna give me -2. So in this case, what I can think of is -4 times 2, because if we add this up, it's gonna be -2. So now that we have that, we can get the vertical asymptote. Why? Because I'm gonna equal that to 0. So it's gonna be x plus 2, x minus 4 equals to 0. So now I know that I have two vertical asymptotes, one in -2 and one in 4. Okay? Now for the horizontal, we're gonna use the most simplified form. So we're gonna look for the degree of each x, of each level. Let me just think it's all, there we go, for it to be more clean. Okay, so we're gonna look at the degrees. And here we have a degree of 1, and in here the biggest, it's always gonna be the biggest, okay, of each side. Okay, so in this one we have the biggest is 1, the biggest is 2. What can we know from this? Since this one is bigger, the one in the downside, remember, when getting horizontal asymptotes, we have three options. If the degree of this one it's bigger than this one, it's gonna be, the horizontal asymptote is gonna be y equals to 0. If they're the same degree, it could be something like that, could be something like that. It doesn't matter. If they're the same degree, I'm gonna do the constant beside it. So let's say we have this, -3. We're gonna do the division. Okay, so it's gonna be y equals to the upside divided by the downside, which is -1. Okay? And there's another option. There could be no horizontal asymptotes. That happens whenever the upside is bigger than the downside. Could be something like that. I don't know. But if this one's bigger, there's none. Okay? So just remember those properties. And now let's continue with this problem. Okay, so in this case, since we know that degree is bigger on the downside and they're not equal, then we know that y equals to 0. Okay, we know the horizontal asymptote is at 0. And now, can we get zeros? Yes, it has zeros. Why? Because this one has an x here, which can be solved for, we can solve for that x in 0. So how can we get to 0? We do 3x minus 6. 3x minus 6 equals to 0. Then 3x equals to 6. And 6 divided by 3 equals 2. So we know that we have a 0 at 2. Okay? That it's 2, 0. And at last, how can we get the y-intercept? We'll see if we need it, okay? Right now, we're not gonna get it. I'll let you know why it's important later, okay? If we need it. Let's see if we will need it for this type of problem. Okay, so now let's just look at the graphs. we know we're looking for a graph that has two vertical asymptotes, one horizontal asymptote at 0, and one x-intercept at 2. Okay, so let's look. Here's just an intercept at 2, and we have two vertical asymptotes, which is -2 and -4. I mean, -2 and 4. Okay, so this one is an option. This one doesn't touch any, there's no x-intercepts. This one, there are x-intercepts. There are two x-intercepts actually, right here, but they're not the one we're looking for, which is 2. So this one's not it. And then we have this one. It also has a 2. Okay, so this one's also an option because it has two vertical asymptotes and the values we're looking for. Let's see other values. Okay, this one also has a 0. No, this is not it. Okay, because we are looking for an x-intercept at 2. So no, these ones are not it. Okay, so we're in between these two graphs. Okay, so what can we do? We know this. There's like various ways to figure out which one to choose. The simplest form is just to evaluate. In something that you will know, you will get either a negative or a positive. In this case, this is where the y-intercept comes in hand, because what's a y-intercept? Y-intercept, it's the function evaluated in 0. It's going to be the y-intercept. So we could either do that, or we can look at the graphs and let's say, oh, okay, I know that in -4, if it is this graph, if I evaluate -4, it should give me something negative because it goes to this side. If it gives me something positive, because here I have -4, then it's going to be this one. Okay, so you can either do either of those, like any of those two type of solutions. So in this case, let's say we go for the 0, okay, the y-intercept. Okay, so if we evaluate in 0, we're gonna get 3 times 0 minus 6, and then 0 to the second power minus 0 minus 8. So if we do that, we have -6 and -8, which give me a positive value. So I know that is not this one. Why? Because I got a positive value. So I know my y-intercept is from 0, like it's a positive value. I can't actually tell you what value is this one. I think it's divided by 2, it's 3/4. So it's something around here. So we know that's this one, right? I told you guys it's something about here, around here, the 3/4, and look at it's right here. So why not this one? And that's how you can eliminate your options, okay? Okay, let's do the other problem. Remember, the important things to get out of this is either a dot or the y-intercept, but mostly the base of it is the vertical asymptote, the horizontal asymptote, the 0, and the empty dots. If we were to have, in this case, we don't have, okay? So, okay. So in this case, now let's do the other problem. So for this case, we know that this one has zeros. And it actually has 2 zeros because if I factor this, I'm gonna get, let's say this is a process for zeros. If I factor this, I know that -3 times 1, -1 times 3 is gonna give me +2, right? So I know that in this case, if we factorize, so let's just factorize. I know that's x plus 3 and x minus 1, okay? And in here, this can be, you can either equal it to 0, or you can also factorize it. You can do whatever you want, as long as you're able to solve for x. This case is more complicated because you have 2 x's, but in this one, in the end, you will just get like the root. I prefer to factorize, but you can do whatever you want. Okay, so in this case, if I factorize, I can just get out the 2, and I get x squared minus 4. And then if I factorize this, I know that it's going to be something like this. X minus 1 and 2 times x minus 4. Whenever we have a perfect binomial, it's going to be x minus 4 and x plus 4. I mean, whatever gives you the value of 4, so in this case. Okay? So you could either do it that way, or you can just leave it like that, and later when you're getting the vertical asymptotes, just equal this to 0. Okay? So if we go with this function, I can easily get the zeros, which are x at minus 3 and x at 1, right? And in this case, for the horizontal asymptote, we're gonna look at the original one because we didn't eliminate anything, so it stays the same. And we see they're the same degree, right? The biggest degree is 2 in both sides. So we know it's gonna be whatever is on the left side of this divided by this. So the horizontal asymptote is 1 divided by 2. Okay? Y equals 1 divided by 2. And then, at last, the vertical asymptote. I'm just going to erase a little bit here, so just that I can put the process of the vertical asymptote. So in this case, I told you that we have two options. Since it's possible to solve this for x, you could just go 2x to the power of 2 minus 8 equals to 0. And if you solve for that, you will get the same answer. You will get, for example, here we can easily see that since there's no x here, this one will disappear. And we know that x equals to 2 and x equals to negative 2. We'll see we'll get the same if we do this, okay? So I'm going to pass the 8, positive, and then, I'm sorry, I forgot about the 2. And then 8 divided by 2 is equals to 4. And see, we got the same answer. Because the square root of 4 is 2 and negative 2. Okay, so we get the same. Okay, so now we know that there's no empty dots, and we'll see if we actually need this or any other value, okay? I would recommend not to do it until you see that you need it, okay? So we know we have two vertical asymptotes, which are are 2 and negative 2. So here we have 1, which could be an option, because also the horizontal, it's at half. And then we have this one that has negative 2 and 2, but the horizontal asymptote is wrong, so we eliminate it. And then we have this one, which could also be an option. Why? Because we have correctly the vertical asymptote. Okay, could be an option. This one is not an option because the horizontal asymptote is wrong. Okay, so it's again, we gotta think of two. Now let's look at the zeros, because we have the zeros, right? We have two values for zeros, negative 3 and 1. So this one does it have it at negative 3? Wait, was this an option? No, this is not an option. Okay, so do we have a 0 at negative 3? No, this one actually doesn't have any zeros. So I think we got our answer. Let's see. Negative 3, here it is. And positive 1. Here it is. So we didn't have to get this because we were sure of our answer. Correct. So for this one, it's D. For this one, it's D. Okay. So if you have any questions, let me know. But I think this also covers everything we've learned, because you have to figure out the vertical asymptote, the horizontal asymptote, the zeros. If there is any empty dots, we'll have to look for them. And you can just get the y-intercept if you are between two answers, and with any of these values you can't seem to find which one it is, then we just go for this solution. Okay, Yes, that's all for this video.